Hi everyone, welcome to JSET classes. This is the NEET PYQ series of JSET classes. In previous two videos, we have discussed units of physical quantities and error in measurements. If you haven't watched those videos, please go and watch those videos. The links of those are given in the description. In today's video, we are going to discuss some previous year questions of dimensional analysis. So without wasting much time, let's go to the question. So the first question is, dimensions of stress are. So four options are given. This is a question that is asked in 2020. So you know that stress is force by area. Stress is equal to force by area. So to find the dimension of stress, we can divide force and area to get the dimension of stress. And we know that force is mass times acceleration. So therefore we have mass here and acceleration is velocity divided by time, and velocity is length divided by time. So therefore we have L and t raised to minus 2. So this is the dimension of force, and area is length times length, that is therefore we have L square. This L and this L square cancels out, this L moves upward, and we will get m L raised to minus 1 t raised to minus 2. This m L raised to minus 1 t raised to minus 2. So this will be the answer. So the option is m L raised to minus 1 t raised to minus 1. So the option is C. This is a simple question, right? So let's move to the second question. So the second question is, a physical quantity of the dimensions of length that can be formed out of C, G and E square by 4 pi epsilon 0 is, where C is the velocity of light, G is the universal constant of gravitation and E is the charge. So let us understand what is asked in the question. We have to find a physical quantity. So what is the speciality of that physical quantity? We have to find that physical quantity by combining C, that is the velocity of light, G, that is the universal constant of gravitation, and this term, that is E square by 4 pi epsilon 0. So we have to combine C, G and E square by 4 pi epsilon 0 to get a physical quantity, and whose dimension is equal to the dimensions of length. So four options are given, and we have to find out which of these combinations has the dimension of length. So this is a question that is asked in 2017. So please take down the question and try to do the question by yourself, and after that we will find the answer together. We have three things with us. The first one is C, that is the velocity of light, and the second one is G, that is the universal gravitational constant, and the third one is E square by 4 pi epsilon 0. So we have to combine these three things, that is the velocity of light, G and this term, that is E square by 4 pi epsilon 0, to get a physical quantity whose dimension is equal to that of the length. But we don't know how much we should take C, how much we should take G, and how much we should take this quantity and combine to form a, to get a quantity that has the physical dimensions of length. So since we don't know how much we should take, let us put it as x, y, and z. So we are assuming that c to the power x, g to the power y, and e square by 4 pi epsilon 0 to the power z combines together to get a physical quantity that has the dimensions of length. So first we have to find the dimensions of c, g, and this e square by 4 pi epsilon 0. As we know that c is the velocity of light, and the velocity is having the dimension L t raised to minus 1. And the next term is g, that is the universal gravitational constant. We know that by Newton's law of gravitation, the force of attraction between two masses separated by a distance is given by g m1 m2 by r square. From this equation, we can find the dimension of g. These two terms are masses. This is the distance between the masses. Therefore, from this we can write g is equal to f r square divided by m1 m2. Since if both the masses are same, we can write it as m into m. So therefore dimension of g is equal to dimension of f. Dimension of f is force is mass into acceleration. This is mass and acceleration is L t raised to minus 2. And we have r square. Therefore we get L square divided by m into m, that is mass times mass, which we will get as m square. So from these we get the m and m square cancels, this L and L square combines, and we will get the dimension of g is equal to m raised to minus 1 L cube t raised to minus 2. So this is the dimension of g. So we find out the dimension of c and the dimension of g also we have found out. Next we have to find the dimension of this term, that is e square by 4 pi epsilon 0. But we can find it in two ways. The first one is by finding the dimension of charge, then squaring it and dividing it by dimension of epsilon 0. But we have an easier method than this, that is by using the Coulomb's law. We know that by Coulomb's law, the electrostatic force of attraction or repulsion between two charges is given by 1 by 4 pi epsilon 0 into q1 q2 by r square. This q1 and q2 are charges. This r is the distance between these two charges, and this 1 by 4 pi epsilon 0 is a constant. I'm saying this because some of you students who are in the +1 class may not identify this equation. You will study it in 12th. So from this equation, if the two charges are electrons, we can put it as 1 by 4 pi epsilon 0 into e square by r square. Then bringing this r term to this side, we will get f r square is equal to e square by 4 pi epsilon 0. So the dimension of fr square is equal to the dimension of e square by 4 pi epsilon 0. Everyone knows the dimension of f and r square, but it's difficult to remember the dimensions of some terms, but we can find the dimensions of these terms which are familiar to us, and we can equate things like this. So f into r square. So dimension of force is, we know that the dimension of force is mass into acceleration. So therefore we get mass into acceleration is L t raised to minus 2 into L square. So therefore we get the dimension of E square by 4 pi epsilon 0 is equal to this L and L square combines, and we will get m L cube t raised to minus 2. So we have found out the dimensions of C, that is L t raised to minus 1, G, that is m raised to minus 1, L cube t raised to minus 2, and we find out the dimension of E square by 4 pi epsilon 0. So please note it down, and after that we will proceed. So putting these three terms in this equation, we get the dimension of C, that is L t raised to minus 1 the whole power x into G, that is m raised to minus 1 L cube t raised to minus 2 the whole power y multiplied by m L cube t raised to minus 2 the whole power z. So we have to combine these three terms. So in the right side, sorry, in the left side we have m raised to 0, L raised to 1 and t raised to 0. This is the left side, and in the right side we have, first we take the term of m, that is mass. Here we do not have any mass terms, so it is 0. The second term we have y into minus 1, that is minus y. In the third term there is a plus 1, that is plus z. So this is the dimension of mass. And then we have length. For length we have x here, that is 1 into x plus 3 into y. Then we have 3 into z. The next term is time. For time we have minus 1 into x, that is minus x. Then minus 2 into y, that is minus 2y. Then from here we have minus 2 into z, that is minus 2z. By comparing the terms in the left and right side of the equation, we can equate this 0 with this equation, equate 1 with this equation, and equate 0 with this equation. That is, what we are doing is we are equating the powers of the quantities on the left and right side of the equation. So the first equation we get is minus y plus z is equal to 0, or in other words we can write it as y is equal to z. So this is the first equation, and from this term we have x plus 3y plus 3z is equal to 1. But we know that y is equal to z. So I am putting for this z, I am substituting y. So the equation becomes x plus 3y plus 3y. And this 3y and 3y becomes 6y. So I have x plus 6y is equal to 1. So this is equation number 2. And from the third, we have 0 is equal to then what we have? Minus x minus 2y minus 2z. But we know that y is equal to z. So I can put it here as minus x. For this z, I put y. Therefore, it becomes minus 2y minus 2y. Minus 2y minus 2y becomes minus 4y. Minus 4y is equal to 0. So bringing this minus 4y to the other side, I have minus x is equal to 4y or x is equal to minus 4y. So I get x is equal to minus 4y. So this is the third equation. So I know that y is equal to z, and here I get x plus 6y is equal to 1, and here I get x is equal to minus 4y. So I am going to put this value of x here, that is in the second equation. Therefore, x plus 6y is equal to 1, that is the first equation, becomes minus 4y plus 6y is equal to 1, and this becomes 2y is equal to 1 or y is equal to 1 by 2. And from this first equation we know that y is equal to z. Therefore, z is also is equal to 1 by 2. So we get the value of y and the value of z. And from these two, we know that x is equal to minus 4y and y is equal to 1 by 2. Therefore, x is equal to minus 4y and y is equal to 1 by 2. So x becomes minus 4 into 1 by 2, or x is equal to minus 2. Okay, so we get the value of y as 1 by 2, the value of z as 1 by 2, and the value of x is equal to minus 2. So we have to put these three values, that is x, y and z here, and we will get the answer. So please take it down, and after that we will write in the next page. X is equal to minus 2, y equal to z is equal to 1 by 2. Putting these, we have c to the power minus 2 g and this term together 4 pi epsilon 0 the whole power 1 by 2, that is equal to 1 by c square, right? C raised to minus 2 becomes 1 by c square g e square by 4 pi epsilon 0 the whole power 1 by 2. So this will be having the dimension of length. So the answer is so from the options we will get 1 by c square, these two have 1 by c square, 1 by c square, 1 by c square, and the difference is here g is the denominator, here it is in the numerator. Okay, 1 by c square g e square by 4 pi epsilon 0 the whole power 1 by 2. So D is the correct answer. So the third question is, if energy E, velocity V and time capital T are chosen as fundamental quantities, the dimensional formula of surface tension will be. So we know how to find the dimensional formula of surface tension, but that is when we have mass, length and time as fundamental quantities. But we are supposing that we have energy, velocity and time as the fundamental quantities. Then what will be the dimensional formula of surface tension? So this is the question. So this is asked in 2015 and the options are E v raised to minus 1, t raised to minus 2. Option B is E v raised to minus 2, t raised to minus 2. C is E raised to minus 2, v raised to minus 1, t raised to minus 3. And D is E v raised to minus 2, t raised to minus 1. Okay. So take down the question and try to do the question by yourself. And if not, we can do it together. Okay. So take down and try it. Okay. Energy, velocity and time as the fundamental quantities. So we have energy, then we have velocity, then we have time. These three are the fundamental quantities. So by comparing these, we should have to find the surface tension. This is the same as we have done in the earlier question. So what we do, we will put here as x and we have y here and z here. So energy to the power x, velocity to the power y and time to the power z. Okay. So what is the dimension of energy? We know that both energy and work have the same dimensions. And what is the dimension of work? Work is having the dimension of force into displacement. And what is the dimension of force? The dimension of force is mass into acceleration, ml t raised to minus 2 with multiplied by dimension of distance, displacement. That is the dimension of displacement, that is the distance is L, and this L and L makes it as L square. So the dimension of energy is same as the dimension of work and we get it as ml square t raised to minus 2. So we can put it here. The dimension of energy is m L square t raised to minus 2 the whole power x. The dimension of velocity is displacement by time, or it has the dimension of length by time, y, and we have time to the power z. In the left side we have the dimension of surface tension. So surface tension is having the dimension of force divided by length. Force by length. So force is having the dimension of mass into acceleration divided by length. So this length and length cancels and we get the dimension of surface tension as dimension of surface tension is equal to m L raised to 0 t raised to minus 2. So this is dimension of surface tension. Okay, so putting it here we get m L raised to 0 t raised to minus 2 on the left side. On the right side we have mass. As in the previous case we have 1 here, therefore x, there is no mass terms here, so 0 plus 0. Then we have to take the length, that is L. This is the dimension of mass. Dimension of length we have 2 into x, that is 2x, 1 into y, that is y, and there is no term for length here, therefore 2x plus y. Therefore we have 2x plus y. And the next term that is we having is the time. This is 2x plus y. The next term is time. For time we have minus 2x minus y plus z. Okay. Therefore minus 2x minus y plus z. So equating these two terms, that is, it is m raised to 1. So we get from the first equation as x is equal to 1. This is the first equation. The second equation we get 2x plus y is equal to 0. But we know x is equal to 1. Therefore, putting this x here, x is equal to 1 is substituted here, and it becomes 2 plus y equal to 0, or y is equal to minus 2. And the third, this is the second what we get. And the third we get minus 2x minus y plus z is equal to minus 2. But we know the x is equal to 1 and y is equal to minus 2. So putting these two here, we get minus 2 into 1, that is minus 2. And y is minus 2. And we have minus of minus 2, that is plus 2. Plus z is equal to 2. Minus 2. So this plus 2 and minus 2 cancels, and the value of z is minus 2. This is equation number 3. So here we get x is equal to 1, y is equal to minus 2, and z is equal to minus 2. So putting these three values here, we will get the answer. So I think you have understood this. So please take it down, and the next page I will write the answer. Okay, so please take it down. So we get x is equal to 1, y is equal to, z is equal to minus 2. So putting these here, we get energy raised to 1, velocity raised to minus 2, and time raised to minus 2. So this is will be having, so this is the surface tension. So we have e raised to 1, e raised to 1. So these e raised to minus 2 and t raised to minus 2. So option B will be the answer. Okay. So this was easy and it was similar to the first one. So please take it down and we will do the next question. Dimensions of critical velocity Vc of a liquid flowing through a tube are expressed as eta raised to x, rho raised to y, and r raised to z, where eta, rho, and r are the coefficient of viscosity of liquid, density of liquid, and the radius of the tube respectively. Then the values of x, y, and z are given by. So we have to find an equation for critical velocity, and this involves terms such as coefficient of viscosity of the liquid, then the density of the liquid, and the radius of the tube through which the liquid flows. So this question is similar to the previous question we have done. So you have to find the values of x, y, and z, and the options are minus 1, minus 1, minus 1, 1, 1, 1, and 1, minus 1, minus 1, minus 1, minus 1, 1. So this question is asked in 2015 NEET. So take down the question and try to do it by yourself. So try, and after that we will do it. Okay. we have critical velocity, and we have to relate it with the coefficient of viscosity, density, and the radius of the tube which through the liquid flows. As similar, we put it as x, y, and z. This eta, we can find it using the Stokes equation, 6 pi eta AV or RV. Therefore, eta is equal to F divided by 6 pi R into V. 6 pi R into V. Where this R is having the dimension of length, V is velocity, F is force, pi is a dimensionless constant. So the dimension of eta, that is coefficient of viscosity, is equal to dimension of force is mass into acceleration, that is ml t raised to minus 2, divided by dimension of length, that is L. Dimension of velocity is L t raised to minus 1. Okay, so this L and L cancels, and we have what we have here is m and L raised to minus 1, and this t raised to minus 1, when it goes up it becomes t raised to plus 1, and t raised to minus 2 plus 1, that is t raised to minus 1. So this is the dimension of coefficient of viscosity. And we know the dimension of density is mass divided by volume, that is mass divided by length into length into length, this ml raised to minus 3. R is again the radius of the tube, therefore it having the dimension of length. So we have velocity here, again velocity here, critical velocity. The dimension of velocity is Lt raised to minus 1, and the dimension of coefficient of viscosity, we find it as m L raised to minus 1 t raised to minus 1. And then we have is density, that is ml raised to minus 3, and then we have length, okay, therefore eta raised to x, density raised to y, and radius raised to z. So we have here m raised to 0, L raised to 1, t raised to minus 1 is equal to m raised to x plus 1 into y is y, 1 into x, 1 into y. There is no m term, therefore we have 0 there. Next we have length minus x, then we have minus 3y, then we have plus z. Okay, and the last term is of time, minus x, there is no time term here, and also here, so only minus x. Therefore x plus y is equal to 0 is the first equation, or we can write x is equal to minus y. And from the second we get we can write the last equation first, that is minus 1 is equal to minus x, that is minus 1 is equal to minus x, or x is equal to 1. X is equal to 1 means, that is minus 1 is equal to minus x, therefore x is equal to 1 means y is equal to minus x, therefore y is equal to minus 1. Okay, and for the final we have minus x minus 3y plus z. This is the second equation. So minus x minus 3y plus z is equal to 1. Therefore, but we know that x is equal to 1. Therefore minus 1 minus 3 into y is minus 1. Therefore, minus 3 into minus 1 becomes plus 3 plus z. Okay, plus z. Z is equal to this, equal to what? Equal to 1. Therefore, we have plus 2 plus z is equal to 1 and z is equal to minus 1. So x is equal to 1, y is equal to minus 1 and z is equal to minus 1. Okay, thus we get the values of x as 1, y is equal to minus 1 and z is also equal to minus 1. So this is the answer. So let's check the options. X is equal to 1, y is equal to minus 1, so this will be the answer, and z is equal to minus 1. So option D is the correct answer. So I hope you understood this question. So let's move to the next question. If force, velocity and time are taken as the fundamental units, then the dimensions of mass are. We have to find the dimension of mass treating force, velocity and time as fundamental units. You can attempt this question in the same pattern I have done the previous questions, but there is another method to do this question. First, you try it with the same method we done in the previous 4 questions. After that, we will do it in a different way. Okay, so let's do it. I hope you have got the answer by doing the previous method. That is, we have to find the dimensional formula for mass in terms of force, velocity and time by using this we can find. But for NEET, as we know, time is a very important factor. So for some problems we can use some short tricks to do these problems like this. So I'm going to give you 2 methods to do problems like this. So here is method 1. So actually we have 3 methods. The first one is the other one is the usual one, and these two are these short trick methods. So I'm giving it as method 1. We know we have to find mass, right? The dimensional formula for mass. We have to find it in terms of force, velocity and time. We know that force is equal to mass into acceleration, right? And this acceleration can be written as velocity divided by time. Understood? So here is force. So keeping mass here and by bringing these terms here, we will get mass is equal to F T V raised to minus 1. Okay? Or in other words, dimension of mass is equal to F raised to 1, V raised to minus 1 and T raised to 1. Here is the answer. I hope you have got this answer. So you can get the same answer by doing this conventional method, and here also you will get the answer. Okay, take it down, and after that I will tell you the second method of finding the answer to these questions in a different way. Okay, take it. So let's do the second method. This method we are doing it by checking the options. So I will tell you how to check the options. So the usual method, we do it by comparing mass with force, velocity and time, and we will try to find out the coefficients, right? So what is the unit of mass? The unit of mass is kilogram, right? You have to keep this thing in your mind. That is, unit of mass is kilogram. You have to keep this thing in your mind. Then what you have to do is, you have to check whether these three terms together gives this unit kilogram. If you don't understand, watch. Force. What is the unit of force? Unit of force is Newton. But in basic units, we can express it as mass into acceleration, right? Therefore, mass is in kilogram, acceleration is meter per second square. Then velocity. Velocity is meter per second. Time. Time is second, but time inverse is 1 by second. But we comparing these, we won't get the unit kilogram because here is nothing to cancel, and we will get kilogram meter square per second cube. So this is not the answer. The second one, that is kilogram meter per second square. Velocity, that is meter per second, t raised to minus 2. T raised to minus 2. Therefore, we have 1 by second square. 1 by second square. Here also we don't have anything to cancel. So we will get kilogram meter square per second raised to 5. So this also won't be the answer. Okay, right? Kilogram meter square second raised to 5. Now the third option, that is kilogram meter per second square. Velocity inverse. Velocity, unit of velocity is meter per second, right? Inverse of this is second per meter. Okay, I'm writing this just for the sake of calculation. Time inverse is what? 1 by second. So therefore the second and second cancels, this meter and meter cancels, but there is still kilogram per second square. This is kilogram per second square. So this not be the answer. The final one, kilogram meter per second square. Velocity inverse. Velocity inverse is what? Second by meter. T raised to 1. T raised to 1. T raised to 1 means what? Second. From here, second square and second cancels, mass and mass cancels, and we get the answer as kilogram. So this one will be the correct answer. By this method also, you can solve the problems by like this. So thank you for watching the video till the end, because I think by watching till the end, you have got a surprise. Maybe some of you know this method, right? But for those who don't know, this method will help you to save your time, because writing x, y, z and making equations, solving them and finding the answer, it takes a lot of time. But this method is, I think, it's really quick I think you can do the same method for the third question. So that's a homework for you. I hope you have understood all these problems. You can tell your doubts in the comment section. Also to tell the suggestions for the betterment of these videos. If you like my content, you can subscribe to my channel, and also don't forget to press the bell icon to get more notifications about my future videos. So do more problems like this, and so that it will be helpful for you in your NEET exam. So keep on studying. God bless you all. Thank you.